Hi guys. So it would be better if someone just mentions the topics which are going to be there in Maths 2 for Rajajinagar. You can send it across on the WhatsApp group, or you can send it. You can post it on the comment section also. So what is the portion for the upcoming test on Monday? I believe, right? Triangles, statistics, triangles, and trigonometry. So trigonometry we had covered once in the class. Any particular problem in that, what you can do is you can send that particular query, and we will solve and send it back to you. So that's one. And now here we have, let me just put the names first. So we have triangles, then we have trigonometry, and third is statistics. Yeah. So if you have any particular concept or thing in particular, to be to do the revision for once again, then we'll take that up. So you can mention that in the comment section. So triangles also, we had one session where we discussed, if I have to summarize, we had these things in triangles. First thing was basic proportionality theorem. Which is also called the Thales theorem, BPT. And the converse of this, then we had, this is 1, this was 2, then we had midpoint theorem, then we had angle bisector theorem, angle bisector theorem. These theorems we revised the other day when we had a live session, correct? And then we discussed criteria for similarity of two triangles. Similarity of two triangles. Okay. Okay, and then the sixth criteria for similarity, and then we also did this theorem, that ratio of area of two similar triangles ratio of area of two similar triangles is equal to ratio of squares of corresponding sides. Okay, basic proportionality theorem, converse of BPT, midpoint theorem, angle bisector theorem, and everything, we had converses of them as well. So it also had a converse. And this also had a converse. And then we had, seventh one was very famous Pythagoras theorem. Pythagoras theorem. Okay, and its converse. Yeah, so we had a scheme, and the scheme was that here we didn't use similar triangles. We didn't use similar triangles for this. Similar triangle for this. Yeah, and for all others, we are very comfortable using similar triangles and using the uh, conditions of similarity to prove all other theorems. Okay, so yeah, and then we also I'm just going through all the topics which are there for R&R this exam. The coming exam is, I think, Maths 2, right? So one thing which I have not discussed, maybe we can discuss today, is the statistics part. So we'll take up in in the later part of the class today, that also, and trigonometry. And this is just to summarize all this so that you have a complete picture of what else was there, what else is there in your syllabus. So in trigonometry, we had what? First of all, basic t ratios. So let's say we are talking about now trigonometry. Yeah. So one is basic t ratios. Wait a minute. Let me just I'll write it afresh. So basically, it is okay. Trigonometry. So one was the basic t ratios, trigonometric ratios, the 6 ratios, and we discussed this also, the six t ratios. And then we had uh, trig ratios, trig ratios of standard, or some some standard angles like 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay, and then we had complementary angles, where we studied what? Sine of 90 minus theta was equal to cos of theta, and vice versa, things like that, complementary angles. And then we learned trigonometric identities. Yeah, so this was the summary. This is the summary of your trigonometry. The heights and distances are not included. Okay, now and then statistics, which these are the topics that primarily in your 10th standard is mean of discrete data as and then classified data. So let's say mean of, let's say, discrete data, and data which is clustered or classified, class intervals, right? Mean, then we found out median. We had median of the same, again 2, and then mode. Yeah, in mean we will be learning 3 different methods of finding mean. Median again we'll discuss, and then time permits, mode. So these are the total thing in the 3 chapters, I believe. Anything else is there in your syllabus, guys? Rajajinagar people? Yes, you can just take your time and tell me anything else is there in your syllabus, or else what I'll do is I'll go through the previous year questions or the CBSE questions on all these topics, and you guys can start trying them one by one. Okay, so let me just, yeah, and a few people have posted some queries also. We'll try and solve that. Just a minute. Wait a minute. I'll get you some questions. Good. So these 3 chapters for, so let me Go to triangle first and let me give you questions on triangles and let's solve. Triangles, very good. Okay. So just a warming up question first of all. So let's take question number 1. Yeah, solve this, guys. In the figure ABC, triangle EDC and triangle EDC, if we have AB is 4 centimeter, ED is 3 centimeter, CE is 4.2 centimeter, and CD is 4.8 centimeter, then find the values of CA and CB. Yeah, try and solve this question. Yeah, do you understand the question? So solve quickly and tell me the answer. You can post your answer in the comment section. Okay. Yeah, everyone has done it. So the question says, so this will be, one of the one marker maybe. So you will use BPT here, right? So what does the question say? The CBSE question, triangle ABC and EDC. If we have AB is equal to 4 centimeter, AB is 4, and ED is 3, okay, and CE is 4.2. This is CE is 4.2, and CD is 4.8. 4.8. Then you have to find out the values of CA and CB. How is it D? How is it D? How do you know that these two, if is ED given parallel to AB? So if ED is given parallel to AB, then there is no problem. Then you can easily find out. But if it is not given, then so there is no mention in the question that ED is. Yeah. So basically, if they are not similar or if ED is not parallel, you cannot. So all of you did this, assuming that ED is parallel to. Actually, there is one thing which is missing here is in triangle. In the figure, ABC is, let's say they are giving similar to triangle EDC. ABC is similar to triangle EDC, and then you can find out the answer to be D. Okay, so I'm not going to do the calculation part here. Okay, never mind. So let me solve our take this sum. Question number 2. Solve this question now. In the given figures, triangle ODC is similar to OBA. It's given. Okay, let me just mention the point so that it becomes visible. So D, this is C, this is A, and this is B. This angle is 125 degrees given, and this angle is 70 degrees. So this angle is 70 degrees. Okay, so BOC is 125, and yeah, find DOC. So quickly do this and tell me all the answers. So D, this point is O. DOC will be how much? These are 2 market questions. Yeah. So what is 55? DOC is 55. That's very simple. No brainer. Linear pair. Find DCO. DCO is also no brainer. DCO is 55. Is it? 70 and 55 and 55. Yes, DCO is also 55. OAB. OAB is 55. Yep. And OBA. OBA is 70 degrees. Correct. Ananya, good. So this is a 2 mark. Let me intensify a bit. Okay. Okay, so most of these will be proof based questions, so hence we'll not be able to communicate back. But let me take questions myself and try and explain it to you so that your fundamentals are revised. So let me take a question like that. I am going to solve this question here. So this question says that in the given figure QT by PR. Okay, so QT. So let me draw Q. This is T. This is P, and this is R. This is S. Okay, and it is said that QT upon. Okay. So what's given? You guys can also try if parallelly if you want to try, but I'll solve it. So given what? QT by PR is equal to QR by QS. So let me see what is it. QT by PR, PR, okay. QT by PR is equal to QR by QS. Okay, fair enough. And angle 1 is given as angle 2. this angle 1 and angle 2. Prove that. Also given is angle 1 is equal to angle 2, and you have to prove that triangle PQS is similar to triangle PQR. Okay, so I'll give you 1 minute to try, and then you can suggest where to start. Okay, now if you see, to prove, so this is prove that, right? So this is to prove. So let's start. So from from given, you can see that Q2 by QR is equal to PR by QS. Correct? Okay. I just I brought this QR here down and PR above. So this is fine. Now, if angle 1 is equal to angle 2, then if angle 1 is equal to angle 2, what can I say? So a triangle PQR becomes an isosceles triangle. So PQ becomes equal to PR. Okay. So hence, the first thing can be replaced by. Okay. So what can I say about this? So here, what you see, this particular thing becomes QT upon QR is equal to PR can be replaced by PQ. So PQ upon QS. Okay, so QT upon QR, if you see QT upon QR is equal to PQ upon QS, that means what? So that means triangle QT QTR is similar to, so QT is corresponding to PQ and QR is corresponding to QS. So hence I can say is similar to triangle QTR will be similar to QPS. Very simple question it is. This was actually 3-marker question in some board exam, previous board exam. Okay, so you guys can easily solve such questions. Now, let me take up another question. Okay, so let us say so let me give you this. This is a answer based question, so you guys can also find. Okay, try and solve this. This is question number 4. Yes, correct, Ruhi. So hence, corresponding sides are equal, and yes, one thing which I forgot to mention is that angle Q is anyways common to both. Is common to both the triangles. Both triangle QTR and triangle QPS. So hence by SAS. How is this? By SAS. You know this. Solve this question, guys. In the given figure, D is parallel to BC, and AD by DB is 5:4. Find the ratio of triangle DFE and CFB. CFB, yeah. So ratio of triangle DFE. So DFE, this much. Area DFB and area of this. These two ratio. You have to find the ratio of these. Try for a minute and let me know if you can solve this question. Lushil, you could do it so easily. 25 is to 81. How? Oh, you have to find out ratio of area DFE by CFB. Yeah, correct. 25 is to 81. Which particular law or concept we are using? We are using this. Ratio of areas of two triangles is nothing but ratio of squares of corresponding sides. Yeah. So how is it 25 by 81? Let me solve that. So it's given that AD. So it's given that DE is parallel to BC. This is given. This is given. And also what is given? AD upon DB is equal to 5 by 4. Now, to find what? Ratio of triangle, area DFE by area triangle CFB. Okay, sorry. Yeah. So now how do we find out? So let's say BE parallel to BC. What should come? What should strike my mind? That DE is parallel to BC. Then by Thales theorem or BPT, I know that AD upon DB, or rather the corollary to BPT will be AD upon AD upon AB is equal to DE upon BC is equal to AE upon AC. Yeah. Now this is not direct fallout of BPT. This is because if you see triangle ADE is similar to triangle ABC. And why is that? Angle A is equal to angle A common, and angle ADE equals angle ABC. Corresponding angles. Perfect. Now, hence by AA similarity, we know that triangle ADE is similar to triangle ABC. So from here, this follows. What follows? This ratio of the corresponding sides will be equal. Now, so AD by AB is equal to DE by BC. So what is AD by AB? AD by AB is nothing but AD by AD plus DA. Sorry, AD plus DB. Which is nothing but AD was given as 5 by 5 plus 4, which is 5 upon 9. Now, using the theorem that ratio of areas of, so let's say area of triangle DFE divided by area of triangle CFB will be nothing but square of their corresponding sides. So if you see, first of all, we have to establish that whether they are similar. If they are similar, then I can say that area of DFE and area of CFB is nothing but DE square by BC square. And I know DE and DE square by BC square I just found out, right? So DE square by BC square is DE by BC square, which is nothing but AD by AB square, which is nothing but 25 by 81. Now, obviously, these two triangles are similar. How? Again, so let's say, and before that, you'll have to prove this, that in triangle DFE and triangle CBF, in triangle DFE and CFB, sorry, this is in the order CFB. What will happen? Angle DFE is equal to angle CFB. Why is this? Vertically opposite angles. And otherwise EDF angle EDF or DEF angle DEF is equal to angle DEF is equal to angle CBF. Why? Alternate interior angles. So hence by again AA similarity, triangle DFE is similar to triangle CFB. And hence the ratio of their corresponding side will be, sorry, the ratio of their areas will be ratio of the squares of their corresponding side, and hence 25/81 is the answer. So AA triple A similarity is as good as double A similarity. All right. So we learned that. Yes, Ruhi. So this is about, okay, next. Let me see if I can give you some more problem on this to solve. Okay. Okay. So now, okay, this sheet is done. Let me go to the next one. Yeah. Yeah. Let's try and do this. Take some time and try proving this. So, question. BL and CM are medians of triangle ABC right angled at A. So, given that, okay, so this is A, B, and C. Prove that 4 times BL square, BL and CM, BL. So, BL, CM are medians. Okay, so it doesn't look like a median, but never mind. Let me just redo it. So median will be some point here. Okay, let me, yeah. So hence this is, oh, sorry. So let me, yeah. So very difficult to draw a line on the tab, but never mind. Let me use this. Yes, this, and similarly, this is another median. Okay, so it's given that that this point is CL, right? CM, and this point is L. Yeah. So to prove that 4 times BL square looks like very easy problem. So how do we solve it? So you can use Pythagoras theorem directly. Pythagoras theorem. So hence from Pythagoras, this is 90 degrees. So you can easily write CM square is equal to CA square plus AM square. And hence AM square can be written as half of AB. So hence it is nothing but AC square plus AB by 2 whole square. Because M is the midpoint, because CM is the median. Okay. Now similarly, BL square can be written as AB square plus AL square, which is nothing but AB square plus AL is half of AC square by 2, AC by 2 square. Now hence BL square plus CM square is nothing but AC square plus AB by 2 whole square plus AB square plus AC by 2 whole square. Okay, so if you simplify this, you will get AC square plus AB square by 4 plus AB square plus AC square by 4, which is nothing but, if you take LCM, you will get 5 by 4 AB square plus 5 by 4 AC square. So hence you can write this as 5 upon 4 AB square plus AC square, which is 5 upon 4 AC square. So AB square, if you see, AB square plus AC square will be nothing but BC square by Pythagoras theorem. So I can write BC square, because AB square plus AC square will be BC square by Pythagoras theorem. So hence my equation is BL square plus CM square is equal to 5 upon 4 BC square. So hence cross multiplying, you will say 4 times BL square plus CM square is equal to 5 times BC square. This is what was to be proven here. Yep. So this is the solution. Okay, good. So I think, let us now move on to some other, any other particular question in your this thing, in similar triangles, any particular topic you want me to revisit, some theorem to prove again. So you please remember, there are these things which are there in similar triangles. Basic proportionality theorem, you know the proof how to do it. So we did it last time, where you take a triangle, you make parallel lines, and then you draw perpendiculars and take a ratio of areas. Okay, and yeah, so for the first time you have to take these two triangles, A, let's say B, C, this is D, E. You have to take triangle ADE and EDB. Find the ratio of their area. You will get the ratio in terms of AD and DB. Similarly, on the other side, you drop, you take these two triangles, this and this, and then again find the ratio of their areas. You'll get in terms of AE and EC, and then you can equate both. You'll get AD by DB is equal to AE by EC. Last part again. Okay, so here is the last part. Yeah, so hence this part, I believe you are asking this. AB square plus AC square, Anand, is this. If you see AB square here plus AC square is equal to BC square. So I simply replaced AB square plus AC square by BC square. So it becomes 5 by 4 BC square. And this all started from here, isn't it? So BL square plus CM square is equal to 5 by 4 BC square. So you take 4 on the left hand side, you'll get 4 times BL square plus CM square is 5 BC square. Okay. So this is about, yeah. So, and then I think Mansi had asked a question. Let me see if I can. Yeah, so Mansi had asked this question. The question is, let us try this. And all of you first try this. The question is, there is a, okay. And okay, and here is perpendicular. So the question goes like this. So O, A, F, G. So this is another perpendicular. So this is G, this is C, and this is B, this is D, and this is E. This is the figure. And the question is, in the given figure, OB is perpendicular bisector of the line segment DE. So this is equal to this. So given, what's given? Given is OB is perpendicular bisector of DE. This is given. Then FA is perpendicular to OB, and FE FE intersects OB at point C. OB at point C. Okay, and you have to prove that. You have to prove that. Okay, so this is not given. What is not given? I have. So this is not there. Yeah. So you have to prove that. Prove that OC. Prove that OC into OB plus OA equals twice of OA OB. Okay, so OC times OB plus OA is equal to twice of OA into OB. So twice of OC, twice of OC into OB into OA, or OB plus OA, OB plus OA. Fair enough. Yeah. So is equal to twice of OA, twice of OA, twice of OA into OB. This you have to prove. Okay, so it's perpendicular bisector. It's given. Will you we'll try a few minutes, and then if you can find it out, guys. Yeah, you can also suggest in the comment section what should be the first approach. So what is from the given thing we can say that BD is equal to BE. This BD is equal to BE, and what else? What else is known? FA is perpendicular, and this is also perpendicular. So clearly, if you see, I can see, sense what? I can sense that triangle AFC is similar to triangle BEC, isn't it? This can be said, and hence from here, and what is the condition? Condition is angle FAC is equal to angle EBC, 90 degree both. And second is angle FCA is equal to angle ECB. ECB. Why? Vertically opposite angles. So by AA similarity, we have triangle AFC is congruent to triangle BEC. Okay, that means it will give me what? AC upon CB is equal to AF upon BE. So corresponding sides of similar triangles. Okay. Now I know BE is also equal to BD. So hence I can also say AF by BD. AF by BD. Now AF by BD, if you see, now let us now, given what was given, AF is parallel to BD, isn't it? Why they are parallel? Because this is 90 degrees and this is 90 degrees. AF was perpendicular to OB. Why is this? Because AF is perpendicular to OB and BD is perpendicular to OB, because OB was perpendicular bisector of ED. So hence AF is parallel to BD means what? By BPT you can say OA by OB is equal to AF by BD, isn't it? OA by OB is equal to AF by sorry, not by sorry, this is not by BPT again. Never, but then a direct result of it is not by this, but a direct result of this will be that triangle OAF is similar to triangle OBD. Why? Again, you can put the reasons because of angle OAF is equal to angle OBD, both being 90 degrees, and angle A common. So again, by A similarity, this holds. So that means what I can say that OA upon OB is equal to AF upon BD. Now, why am I doing all this is, see, when I have to reach OB and OA. So if you see, OC is nothing but, or for that matter, OB is nothing but OC plus CB, and OA is nothing but OC minus AC, and there is a ratio between AC and BC. That's what I would later on try and exploit. Okay, so what do I get? Let's say this is 1, and let's say this is 2. So from 1 and 2, let me reduce a little, wait a minute. Yeah. So so now it is visible, everyone. Now what I'm saying is, yeah, so so basically from 1 and 2, what do we get? From 1 and 2, what do we get? We get OA by OB is equal to AC by CB. See, AC by CB was AF by BD, and AF by BD was also OA by OB. So I got OA by OB is equal to AC by CB. Now cross multiply, what will you get? OA times CB is equal to OB times AC. Now CB can be written as, CB is nothing but, CB if you see is nothing but OB minus OC. So I can write this as OA times CB. CB can be written as this. This CB can be written as OB minus OC. I have to now get all in terms of OB minus OC. And now OB was required. And then what is AC? AC, if you see, AC is OC minus OA. Now expand it. What will you get? You will get OA into OB minus OA into OC is equal to OB times OC minus OB times OA. So if you see, this is OB into OA, this is OB into OA, so it is, what will you get? Twice of OA into OB is equal to, this OA OC goes on that side, so OA into OC plus OB into OC, so which is equal to OC common OA plus OB. This is what was to be proven, isn't it? OC times OB plus OA, so OC times OB plus OA is equal to twice of OA OB, twice of. So this is what was the result to be established. Hence proved. Okay, so fair enough. Now, yeah. So Ronak has sent a question. Let me solve that. Okay, the question is this. It looks like, okay, two poles of height A meters and B meters are P meters apart. So let's say, prove that the height of the point of intersection of the line joining the top of each pole. Yeah. So let's say they are giving, this is A, this is next question. And there is B. Two poles of height and A and B, and they are P meters apart. So this is P. This is P. Okay. Where did OC go? Second last step. Aishwarya. Second step, where did OC go means? OC is still there in the second last step. So this OBOA went to the left hand side and this OAOC went to the right hand side. Okay, so I took OC common between these two, and hence within brackets I can write OA plus OB. I hope this is clear to you. Look, so I'm coming back to Ronak's question. So A, B, and P, okay, two poles of height A meters and B meters are P meters apart. Prove that the height of the point of intersection of the line joining, that the height of the point of intersection of the line joining the top of each pole to the foot of opposite pole. Okay, so they're saying this is the top of the first, and then this is the line joining the top of the one pole to the foot of opposite, and this is the another line. And they're saying they're in the, so they're saying height of the point of this. So this height, let's say this is H. Prove that the height is given by AB by A plus B. So you have to prove that H is, that's what they're trying to prove. Yeah. So two poles of height A meters and B meters are P meters apart. Prove that the height of the point of intersection of the line joining. So let's say this is pole AB and this is CD. Right? So point of intersection be, let's say O. Step before that, just a minute. One is again asking a question, where did OC go? Which OCC is talking about? OB. Let's reconnect after the this thing. Vani, I'm not able to understand. Sorry, Aishwarya, I am not able to understand which one is the step you're talking about. So we'll reconnect after. You can just take a snap and we can discuss it after this class is over. Now coming back to the question, so you have to find out H in terms of A, B, and A plus B. Fair enough. So this is a case of, again, similar triangles. Lots of similar triangles are there. Similar triangles. So if you see, what all similar triangles can you see here? So if you see, and we have, so basically triangle, let's O, and let's say this point is capital P. So triangle, what all? BOP is similar to triangle BCD. BOP is similar to BCD. Why? I can write the reason. So angle CB, sorry. So angle CB, CBD is equal to angle OBP. This is, and then what I've done, this is clearly 90 degrees. So angle OPB is equal to angle ODB, which are both are. So they are similar. So what can I say about it? I can say that, and let's say this side is X. So this is X. So this becomes P minus X. Okay. So I can say, what can I say about H? So if you see H upon B, small b, is nothing but X upon P, isn't it? H by B, so ratio. So H ratio of, or basically if you want to write in terms of this thing, so OP upon CD is equal to BP upon BD. CPST, corresponding parts of similar triangles. So what is OP? OP was H. What is CD? CD was B. What is BP? BP is X. And what is BD? BD is total P. So hence this relationship. Yeah. Similarly, if you see in triangle, again A, D, B, and triangle O, D, P. If you take them, they are also similar. How? Angle D is common, D is common, D is common, and D is common, and another angle. What is it? Angle OPD or angle ABD. Let's ABD is equal to angle OPD. Both are 90 degrees. So again, by AA similarity, let me just take this. Let me write it here. So by AA similarity, AA similarity, I will say triangle ADB is similar to triangle ODP. Okay, hence again I can say what? I can say H upon A now is equal to P minus X upon P, which is nothing but 1 minus X by P. Okay, 1 minus X by P. Now this was my 1 and this is my 2. Okay, let me copy both of them and write it together. So let's say, okay, let us take it here. This is one relation, and the second relation is this one. These two relationships. So I have these two. One is this, and another one is this. Okay, so if you see, so let me simplify. So by first one I say H by B is X by P, and from the second one I can say H by A equals to 1 minus X by P. So this implies X by P is nothing but 1 minus H upon A, and then hence I can replace X by P here by what? This 1 minus H by A. So let's replace that. So hence H by B is equal to 1 minus H by A. Okay, so this implies, let's take H on one side plus H by A equals 1. This implies H common 1 by A plus 1 by B equals 1. This implies H A plus B by AB equals 1. So this implies H is AB upon B plus B. Okay. Yeah, so Neha has also sent some question. Okay, let's solve this. Is this understood? Ronak, you got the solution now? So what is the learning in this question? The learning is, many people ask this question, where to start from? Okay, so the answer is you can adopt one method, and that is called, you can reverse engineer it. Let's say you are supposed to find out H in terms of AB and A plus B. AB by A plus B, right? So you have to, and then it looks like lots of similar triangles are here. So hence, if you write H in terms of A and B itself, then there is a possibility of, right? So hence I chose those triangles where H, A, and B all are involved. So in the first case, I chose where H and B was involved, and the second case I chose where H and A was involved. And thankfully, I got a relation between X by P, and hence I could eliminate X by P, and then we got that H is AB by A plus B by mathematical manipulation. So one common thing which happens is, do not hesitate to take variables, and but simplify as much as possible, and try and explore that whether you will get some headway here or not. So hence, what did I do? I simply put it as x, and this as p minus x, and then try to write one relationship between h, b, and x and p known quantities. And then similar relationship I try to write between h, a, and x. So in this, the common elements were x and p. So I arrived at a situation where I have x and p in two relationships, and I removed, or let's say eliminated, x and p to find this relation. Okay, let's take up Neha's problem now. So Neha is sending a problem, and she is saying, in the figure triangle PQR, again it is a similar triangle question. Okay, so the thing is, there is a triangle. There is a triangle like that, triangle. And this is QR. Okay, so I join them. So this is P, this is Q, this is R. And they are saying this is S, and this is P. Question is, in the figure, triangle PQR is 90 degrees. Okay. S and T trisect. Okay, so I made a figure. I didn't. No, so let me. So S and T. So let's say this is S, and this is T, and then S, somewhat like that. Okay, and then it is given as trisect. So QS is equal to ST is equal to TR is equal to QR by 3 given. You have to prove that 8 PT square. Prove that 8 PT, where is PT? Okay, this is PT. 8 times PT square is equal to 3 times PR square. 3 times PR square plus 5 times PS square. 5 times PS square. Yeah, so 8 times PT square is 3 times PS PR square and 5 times PS square. So I think this is a direct application of Pythagoras theorem actually. So you don't need to do much here. So what you need to do is you write, there are 3 triangles with 90 degrees in each, right? So you can write in triangle PSQ. So in triangle PSQ, what is it? PS square equals PQ square plus QS square, which can be further written as PQ square plus QS. QS was QR by 3 from here. So I can write QR by 3 whole square. Now, why did I do this? Because, yeah, the question talks about, wait a minute, PQR, so PS. So if you see, I have started with PS. Okay, so I'm getting PQ and QR. So I can get all these PT and PR in terms of PQ and QR. See how? So this is nothing but PQ square plus QR square upon 9. So let me write these equations in summarized way here. So PS square is equal to PQ square plus QR square by 9. This is equation number 1. Similarly, in triangle PTQ, I have PT square equals PQ square plus QT square, which is nothing but PQ square plus QT will be 2/3 of QR, because T trisects the side. So hence you can write PQ square plus 4 upon 9 QR square. So let us write it here again. So PT square is equal to PQ square plus 4 upon 9 QR square. Now pay attention. What am I trying to do? All the 3 terms which are here, PT, PR, and PS, and I am trying to write them in terms of PQ and QR. All of the 3 I'll write in that in terms of PQ and QR, because Once I am able to equate the right hand side, then automatically this particular relation will come out. Okay, next triangle. Now in triangle PRQ, you know very easily, PR square is equal to PQ square plus QR square, isn't it? So let's write it here again. PR square PQ square plus QR square. Now let us find out 8 times PT square. Okay, 8 or let us start from this RHS side. So RHS is, let's find out 3 PR square plus 5 PS square. Let us do this. 3 times PR square. So I will use the third equation. So 3 times PR square is nothing but 3 times PQ square plus 3 times QR square. And what is 5 PS square? So from 1, it's 5 PQ square plus 5 by 9 QR square. Okay. So hence, if I add all of them, it is 8 PQ square plus, so QR square is common here. So 3 plus 5 by 9 QR square is 27 plus 5, 32, which is, if you take 8 common, you will get PQ square plus 4 by 9 QR square. And if you see there is a resemblance. This right here, so you will get 8 times. This is what was to be. Neha, you got it? So 8 times PT square is 3 PR square plus 5 PS square. So what is the learning in this question? So the moment you get such kind of a question, you try to express all the terms in terms of known or in same set of variables or whatever, you know. So hence what did I do? I expressed all the 3 terms PT, PR, and PS. And why did I even think like that? Because the moment there is a square in a triangle, there is a 90 degrees, the first thing which comes in our mind is Pythagoras Theorem. So hence I can easily express PT, and it was given that S and T trisects. So even, you know, more, you know, much better. So hence, what did I do? I expressed all these PT squares. So clearly there are 3 hypotenuses, and the 3 hypotenuse I expressed in terms of base and height. And thankfully, the base and all the bases were related to each other. Yeah, because S and T was trisecting the base. So hence I can get a relationship where all the 3 hypotenuse can be expressed in the same, you know, base and altitude, and then we expressed that, and we started with RHS, ended up with LHS. Got it? So this is how. So the moment you see squares and triangles and right angles, then you know it is a case of Pythagoras Theorem. Okay, so I hope Neha got the solution. Now she has sent one more. Let me see. What's that question? So the question is, okay, let us go to the next question she has posted. Okay, so the question is here. Question is, next question. Question says, from a point O in the interior of a triangle ABC. So let's make a triangle. Okay. So this is a triangle. Okay, don't go by my drawing. It's very difficult to draw on the tab actually. Nevertheless, so from a point O, so in such case, take a random point O. In the interior of a triangle ABC, perpendicular OD, OE, and OF are drawn to the sides AB, BC. Okay, so A, B, C, and then they're saying perpendicular OD is on BC. So OD. Okay, this is point O. Then this one perpendicular and this perpendicular. 3 perpendiculars are drawn. So perpendicular OD is on BC. So OD, and then OE is on CA, OE and OF. There are 3 perpendiculars like that. Very good. Now, prove that. First is, let's prove one. First, you have to prove that AF square plus AF, okay, plus BD square plus CE square equals OA square plus OB square plus OC square minus OD square minus OE square minus OF square. Guys, the moment you see such kind of a problem, what comes to your mind first? It's a clear cut. Again, there's a triangle, there are perpendiculars drawn, and there are, there talk of things like OA, OB. So let's join OA, OB. So this is this is OA, OB, and OC. Right? So again, I obtained what? A lot of right angle triangles. So I'll use that property, the beautiful property of a right angle triangle, and that is called Pythagoras theorem. And there are squares, so all are actually, compelling me or directing me to use. The rest is mathematical manipulation. So when I know that this is going to help me, the rest is, yeah. So if you see AF square, let us write down what is AF in terms of, okay, if you see on the right hand side, you have OA and OF and all that stuff. So hence we can clearly write OA square is equal to OF square plus AF square, or AF square is equal to OA square minus OF square. Now if you see carefully, I got OA square minus OF square, right, is AF square. Similarly, all I'll get, and the problem is solved. So hence BD square, now BD square will be BD square. Where is BD? This is BD. So in triangle OBD, BD square is nothing but OB square minus OD square by Pythagoras theorem again. And similarly in triangle, which one now? CE. So you need CE, and okay, so in triangle OCE, you will get OC square is equal to OE square. I'm sorry, OC square is equal to OE square plus EC square, and hence EC or CE, same thing. So CE square is equal to OC square minus OE square. Now if you add 1, 2, and 3, LHS to LHS, RHS to RHS, you will get the desired result. What is it? AF square plus BD square plus CE square equals OA square plus OB square plus OC square minus OD square minus OE square minus OF. Clear? Now there is a second part to the question, and the second part of the question is prove that. Second part of the question is, B part is AF square plus BD square, AF square plus BD square plus CE square equals AE square plus CD square, AE square plus CD square plus FA square, or BF square. BF square. This you have to prove. Again, no brainer. It has to be Pythagoras theorem. Now how? That we'll have to see. So if you see now, what do you get? AX square. So what you can do is from here, yeah. So let's find out AF square. So from here, AF square is OA square minus OF square given. Let us see what is AE, AF, right? So AF, and now let us find out AE square. So if you see AE square, let's write AE square. AE square will be nothing but OA square minus OE square. AE square is OA square minus OE square. Similarly, CD square. CD square will be CD. So this is CD. So this is OC square minus OD square. So you can write OC square minus OD square. And similarly, BF square is OB square minus OB square minus BF, right? So OF square. Yeah, add all of them. Add these three. You will get on the right hand side. You will get OA square plus OC square plus OB square minus OE square minus OD square minus OF square, which is nothing but same as this. If you see now, this part is here and this part is here, which is equal to this. So all are equal. So hence prove. Right. So we have in the previous question we proved AF square plus BD square plus C square is this much, and in this question we proved A square plus CD square plus VF square is also this much. That means this and this are same. Hence prove. Okay. So what is the learning? Learning is the moment you see squares, a triangle, and 90 degrees, then you know what to do. Use Pythagoras theorem. Okay, now Ruby has sent something. Oh, she has sent a solution. Never mind. Any other question on this, guys? So I hope we have done a lot of triangles now. Let us move to maybe statistics. Okay, so statistics, and we'll talk about three ways of finding mean. One is the standard process of finding AM. Then there is something called assumed mean method, and then there is something called if someone is having any trouble in that, then only I'll explain. Trigonometry. Okay, so Ruhi is saying trigonometry. So shall we do trigonometry over statistics? If you have any problem in statistics, you can always post the query to me. Else we'll move on to trig. Okay, anyone who wants anything apart from this, let me know so that we can deal with that as well. Okay, so let us go to trig. Then let me give you some problems to solve. Let me see if you still remember whatever we discussed in the class. Step deviation method. Okay, okay. Wait. Okay, wait a minute. Yeah, Neha, tell me. Send the doubt. Okay, guys, here is the question for you in trig. Okay, let me see what Neha is facing. Okay, Ronak, let me see. Median question. Okay. So who has sent me the 16th problem? Oh, so Mansi is also sending one more. Question is 16. Okay, we'll take one by one. So let me first take Neha's problem. Neha is Sending one more. Okay. Okay. Meanwhile, those want to solve this question can tell me the answer. Aditya says it's 1. Cos square 40 plus cos square 1. 40 minus theta is 90 minus. Yeah. Yeah, it's 1. Good. So let's take Mansi's. Oh, sorry. First of all, again, Neha has sent one more problem. So it's 1. Good. Why is it 1? Because this is cos square 40. This is cos square 50. Now cos 50 is sine 40. So you can replace this by sine square 40. So sine square 40, cos square 40 will be 1. Similarly, this will also will be 1. And here, cos of 40 minus theta is nothing but sine of 90 minus 40 minus theta, which is nothing but here sine 50 plus theta. So hence, these two cancel out. 0 and this is 1 upon 1, so 1. Clear. So Neha sends one more question and says, in triangle ABC, angle ABC is 135 degrees. So 135 ke liye, this is the angle. So this is the angle. This is 135 degrees. And prove that AC square. This is A, B, C, and prove that. Question is prove that AC square equals AB square plus BC square plus 4 times cos of ABC. Okay, 4 of cos of ABC. Perfect. Fair enough. So let's say cos of ABC. If you remember, I taught you sine, cosine, but is this there in your syllabus? But anyways, I taught you this, guys, in class, if you remember. And it will not be, oh, area. Oh, I am sorry. I thought it is an area. I thought it was a cos. I'm sorry. I stand corrected. So it is AC square is plus BC square. AC square is equal to BC square plus 4 times of area of ABC. Okay. When this is 135 degrees, it is given. ABC is 135. Okay. So what question is? Question is AC square, this square, is equal to AB square plus BC square plus 4 times area of triangle ABC. Okay. So let us do one thing. Do these things. But what is, okay. So if 135, draw this. Okay, G, drop. Okay, and then this angle is 45 degrees. Okay, if this is 135, this has to be 45, and this is 45, and this is 90, so this has to be 45. Okay, so that means if this is A, this is also, or let's say this is X, this is also X, this is, both are X. Both are X. Okay, G. Now, let us say this is AC square. Can I say AC square? Pythagoras theorem. Square matlab Pythagoras theorem. AC square matlab in triangle A, let's say D, ADC. So it will be X square, perpendicular square plus BC plus X whole square. Okay, AC square this much. And which is equal to also if you see AB square is equal to X square plus X square, which is 2X square, right? In triangle ADB, this is triangle ADB. No, Ronak, don't complicate. It's very easy. So AB square is 2X square. So X square is AB square by 2. Okay. So hence from this equation, what can I say? AC square AC square is equal to x square. X square is, now let's open this first. So what is it? X square plus BC square plus x square plus 2 times BC times x. Now this is nothing but twice x square plus BC square plus 2 times BC into x. Now it is twice x square. Check AB square. So I can write AB square plus BC square from here, and this is twice BC, twice of BC into x. Now if you see, area of triangle ABC is nothing but half into base. Let's say base is BC, so base into height. What is height? X. X is height, correct? Base and height. Height is this on this base, so x is base, so hence, so twice of triangle, area of triangle ABC is BC into x. So here it was twice of BC into x, so that means 2 into area of triangle ABC, which is AB square plus BC square plus 4 times area triangle ABC. Clear? Neha, got it? Solved. Now let's move on to, someone is sending a question. Sushant is sending, I think. What is it? Okay. Now the question is, let me take Sushant's trigonometry question and then we'll move on to Mansi's question. Okay. Next question is, Sushant is saying, if cosec theta minus sine theta is given as a cube, okay, and then given is secant theta minus cos theta is equal to b cube. You have to prove that a square b square, you have to prove that a square plus b square times a square b square equals 1. Okay, this is what you have to prove. Fair enough. Let's try. Okay, so fantastic. So let us try and simplify this first. So basically, what is a cube? So if you see, 1 upon sine theta minus sine theta is a cube. Why? Because cosec theta is 1 by sine theta. So hence this implies 1 minus sine square theta by sine theta is equal to a cube. Taking it sine theta as LCM, and then 1 minus sine square theta we know is cos square theta. This implies a cube is nothing but cos square theta by sine theta. Okay, similarly, if you find out, you will get b cube is equal to sine square theta by sine theta. Okay, now we have to do a square b square. Okay, now so a cube plus b cube, let me try this way. So you will get a plus b and a square plus b square. So this is yeah, so basically what happened, Ruhi? Oh, I'm sorry. Yeah, thanks for correcting. So this is sine square theta cos theta. Perfect. So a cube I got, and okay, fair enough. So this, where will I get this? If you see, a plus, sorry, a square plus b square whole cube. If you see, what is it? It is a to the power 6 plus 3 times a to the power 4 b square plus 3 times a square b 4 plus b to the power 6. That means it is a to the power 6 plus b to the power 6 plus thrice a square b square upon a square plus b square. So I am getting, here is where I will get a square plus b square. Okay, now let us say, okay, now what? A square plus b square whole cube. Okay, so yes. So what's a square plus b square? If a is sine theta, wait a minute. Cos cube sine theta, yeah. So I have to do this if I somehow find or yeah, or otherwise, instead of that, what I can say, a cube plus b cube whole square is, what is this? A to the power 6 plus b to the power 6 plus twice a cube b cube. This is also true, but then here I got okay, and then so I'll get a6 b6 from here also. So okay, wait a minute. Prove that a square b square is 1. Okay, fair enough. A cube minus b cube is, just a minute, a cube minus b cube is a minus b, a square plus b square. This also will not give me anything. No, I have to use this somehow. Okay. A cube plus b cube. Okay. Okay, let me try that. Okay, so good. Now, this will come out from here only, but this is done. This is cos 4, right? This is a, or let me say, a is cos square theta by sine theta to the power 1 by 3. This is a. If I do 2 by 3, yeah. Yes. One by 3 square, 2 by 3 plus, no. See, this is, you you can definitely do all that. That you can, from here, you can always find a and b and then substitute and you'll get it. But then I'm trying to find out if you can do it through identity rule. So if you see what otherwise you can do, a is this and b is sine square theta by cos theta whole to the power 1 by 3. So if you see what is a square? A square is cos 2 by 3 theta by sine 1 by 3 theta to square. Okay, and b square is equal to sine 2 by 3 theta, then cos 1 by 3 theta whole square. Okay, now let us put a square b square. So you multiply, what will you get? A square b square into a square plus b square is equal to, a square is cos 4 by 3 theta divided by sine 2 by 3 theta times b square, sine 4 by 3 theta divided by cos 2 by 3 theta. This is what you'll get, multiplied by, again, cos 4 by 3 theta by sine 2 by 3 theta plus sine 4 by 3 theta divided by cos what, 2 by 3 theta. So you'll see what will happen. So simplified version will be cos 4 by 3 minus 2 by 3 is 2 by 3 theta into sine 2 by 3 theta. Then take LCM. LCM will be sine 2 by 3 theta into cos 2 by 3 theta. And here it will be cos into cos. So 4 by 3 plus 2 by 3 is cos square theta plus sine square theta. So this goes by this goes by this, and this is 1. Okay, so this is the brute force method anyways, but then if you go through some identity, if you can do that, it would have been simpler anyways. But this is play of your powers. Never mind, there is another question from so many people. Oh my god, wait a minute. Now who's this? Aishwarya is sending one question. So Aishwarya has sent a question. Let me check. Okay. So there is a trigonometric question. Question says tan A is n tan B. Okay. So if given as question, tan of A is equal to n tan B, n times tan B. Okay. And sine A, m times sine what? M times sine B. Okay. Proves that cos square A is m square minus 1 by n square minus 1. Okay, ji. Okay. Cos square A is m square minus 1 divided by n square minus 1. Tan A is n tan B, sine A is m sine B. Okay. Perfect. Now, so let's do. So what is, let's find m. M is sine A by sine B. And what's n? N is tan A by tan B, which is equal to sine A by cos A upon sine B by cos B, which is sine A by sine B into cos B by cos of A, which is sine A by sine B is m. So it is equal to m cos B by cos A. So, okay, now m square minus 1. Okay, let's do this itself. So m square minus 1. M square minus 1 is m square minus 1 equals sine square A by sine square B minus 1, which is sine square A minus sine square B by sine square B. Okay, now what is n square minus 1? Is equal to n, tan a, right? So tan a, tan square a, tan square b minus 1, which is tan square a minus tan square b by tan square b. Okay, let's divide. So m square minus 1 by n square minus 1 will be equal to sine square a minus sine square b upon sine square b into tan square b upon tan square a minus tan square b. Okay, now mm, so okay, we have to get what cos a, right? So we have to get cos square a, but is 1 minus sine square a is. So basically I have to eliminate b. Oh, why am I doing all this? Why? Oh, you don't need to do all this. Sorry, I'm very sorry. What you can do is you can eliminate b itself directly. How? So let's say sine b is equal to sine a by m. So cos b will be nothing but under root 1 minus sine square a by m square, right? Okay. Now tan a is given as n tan b. So n tan b is sine b by cos b. N sine b by cos b. So hence it is n sine b. Sine b is n sine b. Sine b is sine a by sine a upon m, and cos b is under root 1 minus sine square a by m square. Clear? Right? Yeah. So hence if you see squaring both sides, what will you get? Tan square a is equal to n square into sine square a by m square divided by 1 minus sine square a by m square, like that. Okay, so let's now simplify this here. Simplify here from here. Tan square a can be written as sine square a upon cos square a. This is equal to n square into sine square a, and this m square is here by m square whole divided by 1 minus sine square a by m square. If you see, this sine square a and this sine square a will go off. So what do I get? This implies cross multiply, you will get 1 minus sine square a upon m square into m square by n square correct. So 1 minus sine square into m square, yeah. So this is cos square a. So, and what is, I can also, so if you simplify, this is m square by n square minus sine square a by n square. Why? M square and m square will go, is equal to cos square a. Okay, so this implies m square by n square is equal to cos square a plus sine square a by n square. which this implies m square by n square equals cos square a plus 1 minus cos square a upon n square. Why? Because sine square is 1 plus cos 1 minus cos square a. So hence on the right hand side you will get cos square a common 1 minus 1 upon n square and plus 1 upon n square. This is what you will get. You take 1 upon n square on the left hand side, you will get m square by n square minus 1 by n square is equal to n square minus 1 by n square into cos square a. So simplifying, you will get, take LCM and n square, you will get m square minus 1 upon n square is equal to n square minus 1 by n square into cos square a. So hence cos square a is equal to m square minus 1 by n square minus 1. Proved. This is what was to be proved. Yeah, correct. Okay, so I hope you understood. Next question. So next is Neha's question. How did you do fourth last step? 1, 2, 3. This one. This is because this is cos square a plus 1 upon n square. Open it up. Minus cos square a by n square. Now you club them together. I hope this was the question, Ruhi. So if you club them together, cos square a, take cos square a common, 1 minus 1 by n square, and this 1 by n square will come here. Okay. Now let's go to the next problem. So Neha has sent one more question, and the question says, given that 1 plus cos alpha plus 1 into 1 plus cos beta and 1 plus cos gamma is this, show that one of the values of each member is sine A. Show that one of the values of each member of this equality is sine A, sine beta, and sine gamma. Okay, the question is this. Let me, sorry. Let me insert a line. Yeah, next. Question is, given that, what is given? 1 plus cos of alpha into 1 plus cos of beta and 1 plus cos of gamma equals 1 minus cos alpha, 1 minus cos beta, 1 minus cos gamma. Show that one of the values of each member of this equality is, so you have to show that each one could be equal to sine alpha, sine beta, sine gamma. One of the values of each member of this inequality. So if 1 plus cos alpha into 1 plus cos beta into 1 plus cos gamma is equal to 1 minus cos alpha into 1 minus cos beta into 1 minus cos gamma, then sine alpha, sine beta, and sine, both each of them can be of this value. So basically you have to prove that if this is equal to this, So this is also equal to this sin alpha into sin beta into sin gamma. Okay, so how to do this? Fair enough. So okay. So what comes to my mind is you know, if multiply both sides by LHS. Okay, multiply both sides by LHS. So what do I mean? So you do this 1 plus cos alpha, 1 plus cos gamma. You do square here, and let this be k. So you do square here, and what do? You multiply the left hand side, the RHS, sorry, by same quantity, 1 plus cos alpha, 1 plus cos beta. I can do this activity, right? So I multiply both sides by 1 plus cos alpha, 1 plus cos beta, 1 plus cos gamma. Why did I do that? I did that because I can see since here 1 minus, if I multiply this by 1 plus cos alpha, it will become 1 minus cos square alpha. And 1 minus cos square alpha is sin square alpha. So I'll get something of that sort. So hence, if you see, now combine these two. Combine these two. Combine these two. And combine these two. Multiply them. What will you get? 1 minus cos alpha, 1 plus cos alpha. That means 1 minus. Then the second one will be 1 minus cos square beta. Third one will be 1 minus cos square gamma. And this is nothing but sin square alpha, sin square beta, sin square gamma. Now if you see, what did we see? 1 plus cos alpha, 1 plus cos beta, 1 plus cos gamma square is sin square alpha, sin square beta, sin square gamma. If you take away the square root, what will happen? Sine. So if you now square root both sides, what will you get? You will get 1 plus cos alpha, 1 plus cos beta, 1 plus cos gamma will be equal to plus minus sin alpha, sin beta, sin gamma. So one of the values of 1 plus cos alpha, 1 plus cos beta, 1 plus cos gamma is sin alpha, sin beta, sin gamma. Now 1 plus cos alpha, 1 plus cos beta, and 1 plus cos gamma was also equal to 1 minus cos alpha, 1 minus cos beta, 1 minus cos gamma. So hence 1 plus cos alpha is and 1 into 1 plus cos beta, 1 plus cos gamma is equal to sin alpha, sin beta, sin gamma. One value is that, and hence this is equal to this. Proved. Yes. So I hope we could solve a lot of problems today, and yeah. So if you guys have any other problems, then my question. Whose question is this? Mansi. Okay. Wait a minute. Where is this? How to solve 16th question? 16. Okay. Mansi's problem is here. Let's try and solve Mansi's problem. Aishwarya, did you understand? This was Aishwarya's question, right? Who posted this question to me? So this was posted by, I think, Aishwarya, right? No. By Neha. Neha posted this question. So Neha, done? I hope it's done. So now let's go to Mansi's question. Don't feel bad, Mansi. We'll solve your problem also. No worries. Okay. The question is 16th. Okay. The question says, so, oh my God, my note has started misbehaving. So wait a minute. I'll home. Okay. Yeah. So the question is, oh, good. Yeah. So the question says ABCD is a quadrilateral in which AD is equal to BC. ABCD is a quadrilateral in which AD is equal to BC. Okay, then the figure is given like that. So it looks like a rhombus. Never mind. So ABCD is a quadrilateral. This is A, B, C, D. AC is joined. AD is equal to BC. It's given. AD is equal to. Oh, okay. So AD is equal to BC. So this is side is equal to this side. PQRS be the midpoints of AB, AC, CD, and BD. Okay. So let's say this is P. This is Q. I believe. No, sorry. PQRS be the midpoints of AB. So AB is P. AC. AC. Okay. AC. So this is Q, I believe. Q. Then CD. CD. Okay. This is R. And S is of BD. Okay. So let's join BD. And let's say this is the midpoint S. So that PQRS is a rhombus. Oh, PQRS is a rhombus. This is this S. So I'll have to shift Q here somewhere to for a better design, a better drawing that we use. Yeah, fair enough. So we have to prove that PQ. We have to prove that. So it's given that AD is equal to BC, and all these points are midpoints. Hanji. So midpoint, right? So use midpoint theorem. The moment there is midpoint, use midpoint theorem. Yeah. So what will you get if R is midpoint of CD and Q is midpoint of CA? That means RQ will be parallel to AD. So I can clearly say RQ is parallel to AD by midpoint theorem. By midpoint theorem. Similarly, if S is midpoint of BD and P is midpoint of AD, and also RQ is parallel to AD and RQ is also half AD by midpoint theorem only. Okay, similarly, you can find out that SP is half of AD and also SP is parallel to AD, midpoint theorem. Right, so hence what will happen? SP is, so RQ is parallel, so from these two, and RQ is parallel to and SP, sorry, not AD, parallel. So if you combine these two, what will happen? RQ is parallel to SP as well as RQ is equal to SP. Correct? So hence in a quadrilateral, if we have opposite sides parallel and equal, then they are rhombus. Mansi, I hope I could clear this. You can also do the other way around also. So SR will be parallel to BC. Doesn't look like in this figure, but midpoint theorem says that if S is midpoint of DB and R is midpoint of DC, so SR will be parallel to BC and half of it. Similarly, PQ will be parallel to BC and half of it. So I hope we solved a lot of problems, and this was a good, fruitful session for doubt clarification for all of you. And in case before the exam you have some more questions, you can always ping me. You can send me WhatsApp questions, and I'll try and solve them and give it back to you before your exam. So all the best to all of you. Do not panic in the exam. You have done well. You have put in good effort. So you are, way ahead. And I believe whatever we have said, there is no constraint on you. Go there and, yeah, how is it a rhombus? Because PQ is RQ is parallel to SP, and RQ is equal to SP. Similarly, you will get SR is equal to PQ and SR is equal parallel to PQ. So opposite sides parallel and equal. Okay, and since AD was equal to BC, so even RQ will be equal to SR. Okay, so fair enough. So wishing you all the best, guys. Do well and ace the exam. And just let me know after your exam how was your paper. Okay, so I'll be signing off now. In case you have a problem, you know what to do. So thanks for attending this session. If possible, like and subscribe to our channel so that more people could be reached out to. Thanks a lot, guys. Have a wonderful evening and weekend. Bye bye. Take care.